Hello, everyone. Welcome to ITS 450.
Hello.
Hello. Okay, so today we have, as we discussed previously, we have our practical buffer overflow lab quiz exam. So the way this is going to work is I'm going to give you from now until So I'm going to give you from now until, what is it? Let's say 1 a.m., which is, 1 a.m., which is 12 o'clock, right? 12 o'clock tonight. So you have from now until the whole night to solve this. So it's just going to be one problem, and I haven't uploaded the files because I was waiting to upload them at the same time for everyone. So I'll upload two files, and then I will provide kind of a discussion of it, and I need to give you the code as well. Okay, so I'll give you the C code for this, and then I'll let you guys work on it. All right, so the first thing I'm going to do is I'm just going to load the files. So I'm going to go ahead and load the files here. Right, so I need to go to 450. All right, so I already have the module in there, Buffer Overflow 2 practical exam. So you should see that there. And what I'm going to do now is I'm going to add two files. All right. So if you go to that module and you, I guess, refresh the page, you should be able to see the files now. I'm going to share. All right, so you should.
In the practical exam bit, did you hit the button yet or no?
I have. It's not there.
Let me refresh again.
Yeah, maybe refresh the page.
Hey-o, there we go. We're in business.
Yeah. All right. So as I said, I wanted to upload them until the very end. So there they are. As you can see, there's two files there. One is the ASCII table, which you've used before. You should be familiar with that because you used it in the format string lab. And then the other thing I've added is I added a Word document, basically. And it's just, my description of what I want you to do. All right, so let's go over that first. Okay, and I provided a lot of information. Okay, so it's a lot of hints, and it's a type of a scavenger hunt, type of an idea. All right, so this is your practicals. Second, I usually just call it the second. I call it the second buffer overflow lab. In this lab, you will review the principles, but it's it's more of a limited time lab. So you will review the principles of a stack buffer overflow and use them to create your own buffer overflow exploit that spawns a new shell. Now you already know how to spawn new shells, right? Remember that. You have the code for that. Your goal is to insert an input that contains the address to your shell code and get a shell, okay? You must find out this address and figure out how to insert that address through your input, right? So in the previous buffer overflow lab, you guys would read things from a file called bat file. In this one, I'm making it a lot easier because now you can just type things on the command line. Okay, so you can just type things on the, so the program will take in an input with argv and argc, those parameters, right? So you can always just run, dot / myprog space parameter. And that's going to be your input that you're going to be loading in memory. So that's what I want you to do, and I'll give you the code in a second, but here's a few. The following hints may help you to accomplish this task. Number one, you're going to use your seed Ubuntu, the one we've been using before. You're going to create a file called vulnerable.c. There's only going to be one C file this time. So it's not like the lab where you had, stack and exploit and all that. You're just going to have one program, vulnerable.c. And the instructor will provide the code. So I'll give you the code in a second. Then you're going to compile it, right? And you should run GDB. Run GDB, analyze it, do all the analysis that you can do with GDB, all the commands, right? And try to figure out, how to get results from this. You're going to study the assembly code. Remember, you can disassemble main, disassemble function 1, disassemble function 2, right? And you can look at the code, the addresses, etc. So study the assembly code and try to find the starting address for all your functions. In GDB, you're going to enter inputs. See what happens. The program takes an input from the command line. So remember, that's the difference. It's not reading from a bat file. It's just taking inputs from a command. Could you change the code and read from a file? Yes, but why go into all that trouble when you can just do it by hand through the input? So the program takes an input from the command line. Find out the size of the input string required to overflow the buffer. So how do you do that? Insert several inputs, right? See if you get, the errors that you were getting before. Remember, you can disable some of the mechanisms. You can compile with fno stack protector, disable randomization, all that you can do. One suggestion is use a sequence of unique, non-repeating characters and numbers. I think I've said this several times throughout the semester. Just like you were filling things up with no-ops, this time around, actually just try a sequence of unique, non-repeating characters and numbers, A, B, C, D, and the numbers. That will help you to figure out where it's erroring out, right? Because it'll tell you, I read this thing, I thought it was an address, but it was just these letters. Well, at least that tells you where the address is. When you run this sequence of inputs in GDB, GDB will tell you where the program errors out, e.g. 6segv. You'll get that error. And there it'll show you what it read. Find out your target memory location, where you need to put the address in your input. So craft an input that allows you to get a shell. Describe what part of the source code is unsafe and causes the exploit. An ASCII table has been provided to you. This table has hex and char values. The addresses you see may be in hex, but you enter your inputs as characters. Remember that. So when you're typing ABC, you're not entering things as hex. If you type 0x44, it's just going to treat it as 4 characters. So we will need something to deal with that, but I will provide that for you as well. So the addresses you see may be in hex, but you enter your inputs as characters. An address, as you know already, such as 0x44, 45, 46, 47, I just made up an address, is equivalent to 0x44, 0x45, 0x46, etc. Each one of these may correspond also to a letter such as 43 is C in the ASCII table. We saw that in a couple of labs. Additionally, the order when you enter an address may need to be inverted. Remember that. So if your address is 1, 2, 3, 4, 5, 6, it may need to be entered as 6, 5, 4, 3, 2, 1. All right, and that's it. So other than the code, you pretty much have everything that you need to solve this lab, all the suggestions, okay? So remember, it's just one problem. And at the end of the day, I want you to get a shell. All right. Do you need to get a root shell? I'm going to waive that off, and I just need you to get the shell. But I will give bonus points to those students that get the root shell, because as you probably know by now, that involves some additional steps. But you can have randomization off. You know, that's perfectly fine. Okay. Are there any questions so far of what I've said?
I have a question. Do we have to use a special shell like ZSH or Bash or?
That's a very good question, actually. So when we did the last lab, we saw that there's a way to get around even Bash, correct?
Yeah.
Yeah, and so in that sense, and that really only applies if you're going to get a root shell. But remember that I'm saying that you'll get full credit even if you get just a regular shell. If you get a root shell, you have to consider those issues, and I'll give bonus points for that. Make sense?
Yeah.
Yeah, so you have to, I mean, so I guess your question was, could I get a root shell with CSH or Bash? Which one? Either one, as long as you know what you're doing, you know, and you explain, well, if it's Bash, I did this. If it's CSH, I maybe didn't need to do this, and so on. Does that answer your question?
Yeah, so just whichever one we choose, explain it and why.
Exactly right. Very good way of putting it. Whichever one you choose, that's, if you want to make it like the most realistic one, go for that one, you know, or do the other one. As long as you show understanding of it, you know, it's perfectly fine. But the only thing that I'm making required for get full credit on this one is to get a shell. So it doesn't necessarily have to be a root shell, but I'll give bonus points for a root shell. Okay? Any other questions? All right. If there are no other questions, then the other thing I'm going to give you is the code, right? So I'm going to give you the code. So I'm just going to open up a notepad here.
Oh, you're just gonna type it out to us live?
I was, because I was going to explain it. Do you want me to just provide it for you? I could do that too.
So last semester I would get code and it would not work. So 100% it's gonna work, or to the ability of us to figure it out.
Okay, so you want me to write it and compile it and give it to you? Is that what you mean?
Just so I know that it works. Because last semester I had a lot of issues watching you type in code and miss something and then be screwed.
Okay, so you want, I mean, I could type it and just upload it if that's what you guys prefer. I can do that. Either way for me.
That's what I would like. Anyone else?
Which one?
I have it provided.
Yeah, I would rather have it provided.
Okay, so let's do that then. I will type it up and load it up for you guys, and then just be on the lookout for it in about, it'll take me 10 minutes to, I might just have the file somewhere on my computer.
Okay.
Does that work?
Yes, sir.
All right, so then start reading through this and look for the code in about a few minutes, okay?
Thank you very much.
No problem. Happy to do it.
Professor Calix,
Yes, sir.
I have a question for you before you leave about my test.
Yeah, no, I saw your email. I just haven't had a chance to reply. I have to think of what's the most appropriate there. I don't know. Either take it again, or I'll take a look at that file that you mentioned.
Okay.
Okay. So I'll get back to you on that.
All right.
Okay, great. All right, so I'm going to stop sharing, and I'm just going to, the code is not very long, and it's in C, as you probably imagine. All right, guys, can you see the, can you see it?
Yes.
All right, so it should be there. So let's go over it. I could have just have typed it and would, but anyway, it's there. I ran the code here. So let me share the VM. All right, so I've loaded that. So do you see my VM?
Yes.
Okay, great. So the program is called Vulnerable C. Just, you know, as you might imagine, you can see I already compiled it. I already ran it. It'll give you a warning, but that's not an error, right? So it's only a warning. And you can see there, it's executable there, vuln. So if I open it, right, you can see it's very easy. I mean, don't overthink things. It's not meant to be, I'm not asking you to overthink anything. I think this is actually very easy. So we have int main, right? You guys remember that argc and argv allow you to, whatever you type in the command line, it gets passed as a parameter. So what's happening is I have function one. I put these print statements just to help you. just to kind of to know where you are. You can use them for that. argv1 is going to be whatever input you type on the terminal goes to function 1. Make sense? Function 1 is what? It takes a string, right? Pointing to a string. You have a buffer. You should know what you're seeing here. Right? And then notice over here, mysteriously, I have added function 2. But if you read function 2, there's a couple of things in here that should be interesting to you. You have this, right? You're calling sh, and you're also calling execv, which means that you're basically running this command. So in essence, if you call function, one of the first things I would do is I would try to call function 2 from the main and see what happens. Okay. But you can't change, the way that you have to solve this is you won't be able to change the code, right? Remember, the only thing you can do is change the input. So this is the code that I've given you, basically. And so this is the code that you would have to make work here, right? The only other thing I could say is maybe you could add a function 3, and that function 3 just loads shellcode like we did in the buffer overflow lab. But it's pretty much the same thing that you had over there. Okay, so really then, what am I asking you to do? If you notice, function 2 is never called from the main. It's never called from function 1. It's never called, really. However, it is in memory. Does that make sense? Do you understand what I'm saying? The code is never called, yet when you compile, this will be in memory somewhere. So I'm making the problem even a lot easier by not having you insert the shell code through the input. In fact, all you have to insert through the input is what?
Function 2?
Not function 2. Function 2 is already going to be in there, but it's going to be the address to where function 2 will be in memory. Does that make sense?
Yeah.
Yes.
That's it. I mean, so you don't have to inject shellcode, right? Shellcode does not need to be injected. In fact, shellcode is there already. I provided it for you. When you compile this, all of this will be in memory. So it is as easy as that. Figure out where it is, figure out the return address, and when you do your code injection, which will be something like this, right? You will do vol n, right? And then this is what I mean, your input, okay? You type, okay? Now, if you look in the hints, I said type A, B, C, D, E, F, type all of that. Type as much of that as possible until it breaks, right? You saw the size of the buffer there. By figuring out that and looking at where these characters are appearing, right? If you look at that 6sec_v error in GDB, you will be able to figure out, oh, maybe the address should go here. So maybe that's the address. Do you guys see that? That's what I'm getting at, okay? So given that input, figure out where to put the address. Because, A, B, C, D, E, all of that it doesn't matter. But A, B, C, D, E, F, G, H, and then at this point, this is where the address goes. 12, X33, X55, and so on. Do you see that? Now you have to enter the address like this, but unfortunately, if you entered X33, currently it'll be interpreted as X33. You want it to be, you want the whole X33 to be to be interpreted as a hexadecimal address, okay? So that's the last piece of this that I'm going to give you. I'm going to give you a little trick so that it works for you. So all you have to do is, instead of typing it, when you're debugging it in GDB, you can do it like this. But when you're finally ready to enter and to have hexadecimal values in there be interpreted as hexadecimal, what you will do is you will type the following. Where the input would go, where this input would go, you will write this little, the accent symbol that you have in your keyboard. It's on the upper left-hand corner of your computer, right? You have a little symbol under the squiggly line. I forget the name. I think it's called a tilde. And you will type that in there. And then after that, you will run a Perl command. So you will run Perl. And this doesn't have to vary. It's just you type this command, -E. And then in single quotes, you're going to say, so one single quote, another single quote, and now you're going to type print space, and then now in double quotes, you're going to type the actual input that you need to type, so the letters. So in this case, again, as I'm saying there, either uppercase, lowercase. Remember, these are different for different ASCII characters. So you're going to say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, you know, all of that. And then at some point, when you know you have the you have the address, you're going to type for one address. Remember, it's 4 bytes basically, right? So you're going to say \x, make this one a lowercase x, and then let's say your number is 99. Okay, that's 1 bit, just like we did in the lab. Exactly like we did in the lab, only this should be easier. Remember, if it's 43, you don't have to invert it to be 34, right? It's still 43. And then 0x, I don't know, 00, and then 0x 66, and then you can continue with letters. The MNOPQRS. So that's basically the lab. So I'm giving you the mechanism already for the input. You can see it right there. It's right there. All you have to do is figure out, play around with this input. I'm telling you, this is how you should play with it. Do this in GDB. Try lower, but the problem is, where do you put this, right? That's the problem. Do you start at G? Do you start at J? You can also look at the size of the buffer and maybe figure it out that way. I mean, there's a lot of ways of doing it. Then you got to get this address. Maybe flip it, maybe not flip it. I'm giving you the command that you will use. And that's it. I mean, at the end of the day, then, if you got the right address, which is, it's sort of the hardest part. I'm going to type something here so I don't lose this. Nothing will happen. All right, so I tried. See, I ran it, and what happened there? Stack smashing detected. What is that? So what does that tell you guys? You remember,
we need to disable the stack protection.
Exactly. So there's the whole stack smashing. You can see that I ran the code and got to main function. So that's why those printfs would help you, right? But remember also that you're gonna use GDB to figure out that address. Now in the lab, I want to stress, if I wanted to be, make it harder, I could have put the shell code here, right? But we're not doing that. Just keep it easier, simpler. I've given you, I'm telling you right away, right? I'm giving you this function. It should be the exact same function that you guys had in the PDF of your lab. It looks a lot like it. You could use that one also. I mean, but So basically what I'm saying is find the address of function 2. You don't even care what's in here. Find the address of function 2 in the stack, figure out how to align it from your input, and then from there, you should be able to get a shell. And if you get, to make it even easier, I'm not requiring you to get a root shell, but for those that get a root shell, I will provide bonus points for this. And that's it. This lab is worth, as you can see, it's pretty straightforward. It's worth a full lab, as any other lab would be worth. Questions?
So just to clarify, we're not messing with the code in here, right? Like
No.
we're not editing or taking anything out.
You can to learn how it works, but to make it run, yeah, you should only insert through the input, right? You can't just like, for instance, you can't just say function 2 here and then boom, you get the shell code, right? Does that answer your question?
Don't mess with it.
So do we need to write code for function 2 in the main input or the main function?
Nope. No, you
Okay,
just,
so if we just compile this, it should work fine then. We just have to figure out the address and all that.
that's right, the inputs.
Okay.
Yeah.
That's just want to clarify that.
Okay, sure. Just like we did in the lab, right? So the only thing you had to do in the lab is you modify, okay, so I think I know where your question is coming from. In the lab, you had stack and exploit, remember that? You did not touch stack. The only function that you modified was exploit, but that was just to create the bad file. Here, you're just entering everything through the input, so this is just a stack file, basically.
All right, I got it.
Okay, great. Excellent. Yes, you have until, we can make it even 2 a.m., but that's 2 a.m. Eastern, so 1 a.m. Central. So there's no confusion that it is tomorrow at first hour. Yeah, I mean, how many hours do you think you need? I mean, that seems like a lot of hours. You have 6 hours, 7 hours. Do you think you have enough time to work on this, guys? 6 hours, you can do it, right?
I think we should have 6 weeks.
Can't have 6 weeks. Takes the
Figured-
fun away from it. The fun is to get it. I used to do this in the lab itself, and I'd love the stress that I would see in students' faces. But
We can't have
Did
like
you
till
say you love
tomorrow,
stress?
maybe?
Wait a minute. Wait a minute now.
what? I'm sorry. What was that?
We can't have till tomorrow by any chance?
You can have until 1 a.m. Central.
Tomorrow. That is tomorrow.
That is tomorrow. Yes.
I mean. Okay.
All right. I'll be here until the end of class today. So what I would recommend is start working on it right now. And if you have questions, ask them. I think you'll find it's not as difficult as you think. Remember, all you need to do is get that, the little prompt, right? The little $sign. But it has to be the fact that, and the code is already there. You just have to find the address and where to put it in the input, as I showed just now. Okay? Any other questions? All right, it seems like there's no questions. So what I'm going to do is I'm going to pause the recording and I'll mute my mic. All right, guys. Keep working on this. And remember this is due, at 1 a.m. Central. So good luck on your practical. And remember also, before I forget, Tuesday is fall break, Monday and Tuesday. So there's no class Tuesday, and we will meet again on Thursday. All right. All right. So enjoy your exam and have a good fall break.
Okay, bye, Professor. Have a
Bye.
good fall break.
Okay.
Thank you, Professor.